Okay, our goal on this problem is to use the angle that's given to us, negative 5 pi over 6, and ultimately we want to evaluate each one of these trigonometric functions, sine, cosine, tangent, cosecant, secant, and cotangent at this value, at this angle that's given to us in radians. To do so, what we're going to do is eventually we're going to find reference angles to go along with this. Find the reference angle and then evaluate using an angle that we know about. Before we do that, I do notice on this example that we are given a negative angle. I don't like dealing with negative angles, so what I would probably do first of all is I would find a coterminal angle. All right, so to find a coterminal angle, what that means is it's wrapped around either one more or one less time all the way around the circle. So I would start out with my negative angle, negative 5 pi over 6, and I want to make this positive, so I'm going to get a positive coterminal angle by adding 2 pi to this. So I want to add 2 pi, but I'm going to kind of strategically write this because we already have a denominator, right? We're dealing with a fraction. So I'm going to rewrite my 2 pi so it has a 6 as its denominator, and I'm going to write it as 12 divided by 6 makes that 2 with a pi along with it. All right, and as we find these coterminal angles, it's usually not too bad. If it's in degrees, you're going to be adding or subtracting 360. If we're in radians, such as this one, we're going to be adding or subtracting 2 pi. It's just with fractions, sometimes it's helpful to kind of strategically write them. All right, get that common denominator. So as I combine these together, we'll have 7 pi over 6. All right, next, what I would do is just kind of place this in the correct quadrant. So our quadrantal angles, we have pi over 2, pi, 3 pi over 2, and either 0 or 2 pi straight out to the right-hand side. So we have 7 pi over 6. 7 over 6 is improper, so it's not going to be in either one of the first two quadrants. It's less than 1.5 pi's, so it's going to be in the third quadrant. So I'm just going to kind of sketch that in here. Not super accurate, but it's in the third quadrant. That's the important thing as we get moving in the right direction on this. Okay, and on each one of these, when you find a coterminal angle, that doesn't affect any of these as far as the computations go. We can say that sine of negative 5 pi over 6 is exactly the same as sine of 7 pi over 6. And we could write that for each one of these other ones, cosine of 7 pi over 6 on the right-hand side of that equals sine, and so on for all of them. I'm not going to do that, but you definitely could. Finding coterminal angles, you don't have to check the sign being positive or negative. It's going to be the exact same as whatever the original angle was. All right, next, let's go ahead and kind of draw in our reference angle. So we're in the third quadrant. We always have to draw our reference angle to the x-axis. So it would fit right in this portion of our graph. I'm going to go ahead and label that as theta bar for our reference angle. And to do this computation, to get that angle, what we're going to do is theta bar is going to be the further side here, was wrapping all the way around here to 7 pi over 6. So we're going to start with the longer angle, 7 pi over 6, and subtract away the shorter angle. In our case, that was pi. So we can think 7 pi over 6 minus 6 pi over 6 is going to be pi over 6. Slowly comes about here. All right, so that's our reference angle that we want to be dealing with. And I want to substitute that reference angle into each and every one of these. But as we substitute in, we want to be a little bit careful that we want to have the sine of pi over 6 as we plug in that reference angle. But it's at this point that we have to be really, really sure that we're going to be positive or negative in that sense. So how we make that determination is our 7 pi over 6, or if you're thinking about our negative angle, the negative 5 pi over 6 wrapped around in the negative direction. We're in the third quadrant. So we want to use the phrase, all students take calculus. To help us that we're in the third quadrant, only tangent, the very first letter of each one of these words, helps us out in understanding which one's going to be positive in that given quadrant. So in the third quadrant, tangent, T for tangent, is going to be positive, and I guess technically also cotangent will be positive here. All right, so as we think about this, sine, the first one we're trying to evaluate, is going to be negative, so I'm going to make sure I include a negative out in front. Next, we want to evaluate sine of pi over 6. Well, pi over 6 shouldn't be too bad here. That's one of our nice angles. It's equivalent to 30 degrees. So we can use our chart to help us out. That's going to be 1/2 can get filled in for sine of pi over 6. But we do have to include that negative from out in front. Okay, for cosine, it's going to be very similar here. This is going to be the negative of cosine of pi over 6. Again, I included the negative out in front here because we are in the third quadrant and only tangent is positive in the third quadrant. Next, to fill in here, we can go ahead and bring along our negative, and cosine of pi over 6 is going to be square root of 3 over 2. All right, lastly, I'm going to go ahead and get tangent of negative 5 pi over 6. Tangent in the third quadrant is going to be positive. So I'm going to go ahead and just write tangent of our reference angle, pi over 6. And now to evaluate that, it's going to be the square root of 3 over 3. All right. I always focus on these first three, sine, cosine, and tangent. And then as long as we have our reciprocal identities down, that'll help us get cosecant, secant, and cotangent. What I mean by reciprocal identities is each pair, sine and cosecant in this case, one starts with an S and one starts with a C. So these two go hand in hand. Cosecant is going to be the reciprocal of sine. So what that means is if we invert the numerator and denominator, so basically say 2 over negative 1, that'll give us cosecant. Or with a little bit of simplifying down, that's going to be the same thing as negative 2. We can do a very similar thing between secant and cosine. These are also reciprocals of one another. So to get secant, we can invert cosine. So we can say, well, that's negative of 2 over the square root of 3, which is a decent answer, but we could rationalize this denominator by multiplying numerator and denominator both by the square root of 3. In doing so, we can multiply numerators together and get negative 2 times the square root of 3 over the denominator. We can say square root of 3 times square root of 3 makes square root of 9, which will reduce down to be 3. It's going to be very similar for cotangent, that we're going to invert tangent, use its reciprocal. So 3 over the square root of 3, flip it upside down. And then to rationalize here, we're going to multiply numerator and denominator each by the square root of 3. So the numerator in this case is going to give us 3 times the square root of 3. And the denominator, we're going to end up with square root of 3 times square root of 3 makes square root of 9, which works out to be 3 with a little bit of reducing down. And then finally, those 3's that are not underneath radicals, those can simplify down and make a 1. They can cancel out, some people would say, and leaving us with square root of 3 or square root of 3 over 1, which reduces to square root of 3. All right, hope this helps out. Nothing wrong with finding coterminal angles. As soon as you find that reference angle, though, and want to substitute that in for each one of these, that's where you want to be very, very careful about that sign, positive or negative out in front, based on whichever quadrant that initial angle was in, either the negative 5 pi over 6 or our coterminal angle, which lands in the exact same quadrant with its terminal side. All right, hope this helps out. Good luck as you're working through these. Reference angles are super important.